All right. I think we are just about ready here. Oh, current bit rate. Ended. Much about that screen. Screen in OBS. Recommend bit rate is for you. Yes, I think about as good as we can get for now. What is up, C. Grover? Good morning, my friend. Coffee, cheers. Got the old cup of brew going as well. Yeah. All right, there we are. Yes. Good morning. Welcome. Happy Saturday. Hope you all are doing well this morning. If anyone who's watching is new and doesn't know, first of all, thanks for checking out the stream. My name is Tim. I go by Foamy Guy on GitHub and Discord, and I usually stream around this time each week, Saturday mornings, 10 a.m. Central Time. I am usually here streaming stuff related to CircuitPython. Sometimes I'm working on CircuitPython projects, sometimes I'm working on CircuitPython libraries, sometimes I'm working on infrastructure and surrounding stuff. On a rare occasion, I'm working on something entirely different, but most typically, I am here on Saturday mornings working on CircuitPython stuff. If you don't know what CircuitPython is, you can learn more about it at the main website for the project here, circuitpython.org. It is basically a version of Python that runs on tiny computers called microcontrollers, such as all of these ones here. When you use CircuitPython with these devices, that's just one of the ways that you can program them. But when you use CircuitPython, the way it works typically, you plug this device into your computer with a USB cable. It's going to show up like a thumb drive, like a removable storage thumb drive. You can edit a Python code file on that drive. And when you save it, the microcontroller will execute the Python code for you. So you can write whatever code you want the microcontroller to do inside that file. You save it, and the microcontroller runs it for you. We are a little bit removed from that today. Actually, let me finish the rest of the intro, and then I'll catch you up on where we'll be today. We are slightly removed from the microcontroller world. Is where I'll do most of my work today, but it all ties back, and we'll see that in a minute. But for now, let me say again, circuitpython.org, you can come there to learn more about the project. Also, as always, thanks to Adafruit. Adafruit is a hardware and software company based out of New York. They are from the headquarters right now. The factory and everything is in Brooklyn, New York, Industry City. And they make CircuitPython possible by paying a team of folks, including myself, who work on the project. So there are folks who work on the project full-time, there are folks who work on the project part-time, and there are folks that Adafruit pays to work on various other open source maker-oriented projects as well. So if you would like to help support them and all of the open source software that they pay people to work on, one of the easiest ways to do it is by purchasing hardware from them at their website, you can find at adafruit.com. And as the banner here states, if you check it out next month, starting next week, I guess, next month. But in any case, upcoming pretty soon, there are going to be deals dropping to try to clear out old inventory of various things, is from what I understand. So check back for that if you want some deals on whatever kind of stuff Adafruit is looking to get out of the factory. Otherwise, you can always head there and get microcontrollers. You can get things to plug into your microcontrollers to build interesting projects with, all that kind of stuff. And then they do, of course, have the Learn system where you can find all kinds of projects documented. So you can look here for inspiration or even step-by-step instructions for building a specific thing. All right. So with that, I will, like I said, wrap it back around a little bit to where I'm going to work today, which is going to be slightly outside of the microcontroller world. I am looking into a Displayio enhancement, but in an attempt to do a few things. One, to be able to just iterate very quickly on my PC rather than a microcontroller. I'm using Blinka Displayio with this Pygame display library that I created a while ago. So it's helpful in that I can do a bunch of work and iterate very quickly all on my PC without the microcontroller in the mix. And because the Displayio API is the same as what the core CircuitPython has, it means like I can work on stuff that will ultimately also work effectively the same way on the microcontrollers. The other reason why I am using that one today is because we had, let me find the right browser. Let's see. So that is, I think, this one. Yeah. Is that right? Why do I have another? Oh, okay. This is, okay. Yeah. So we want to get to GitHub and Pygame display. So there were, so Hug Report, I'll start with, for Relic SE, there are a couple PRs in for Pygame display. So thanks to them for submitting some improvements there. I am also interested in this one, though I have not looked closer at it just yet. This thing is back to logged out. I swear I've logged in with this before. I guess it wore out. That's interesting. So yeah, thanks to Relic SE for submitting a couple improvements here. So I was checking these out this morning, so I had Pygame display all set up and ready to go anyway. I figured this would just be easy to work on inside of there. That way we can kind of experiment, explore, research, figure some stuff out. And at the end of the day, we know that we can move it into a microcontroller. Maybe slight adaptations for like the display setup is all, but everything after the initialization of the display should be the same. So we have, I imagine folks have seen this before, but just to show where we're working, we have a Pygame display window, so we can spawn this at whatever size we want. I usually try to pick a size that matches physical displays, but in this case it's actually not. 400 by 300 is just kind of randomly chosen. Well, it's not random, it's 4 by 3, but it's not necessarily a typical display size. And so you can initialize it like this, and once it's initialized, you can then do all your normal Displayio stuff. So you can make a group, you can do bitmaps and tile grids, Displayio-based libraries like label, image load, bitmap font, all of these things work inside of here as well. So you can kind of create Displayio-based visual programs that run on the PC, which is really cool. And in particular, I'm looking at the font stuff. So there's a couple font examples. I'll run through them real fast, although some of them are outdated, actually. So like this is showing the outlined label, but if we look in the code here, it's actually using outlined label. And more recently, I did a bunch of work on refactoring display text. And so actually outlined label is now sort of deprecated and tucked into, so to speak, bitmap label. The same functionality now works inside a bitmap label instead. So we could actually switch this over to bitmap label, which I should do at some point, but it's not what I want to focus on today. Scrolling label is actually the same deal. This one runs here too, though, so you can see this one allows the text to sort of do the old marquee sort of action going on there. And I think there's simple test we saw. There's some labels in the simple test. There's one in the middle there, but basically it. And then there's setup only. So setup only just initializes the display, but doesn't draw anything. I'm actually going to just copy paste that one. It's kind of like a template to make the rest. And I am just going to put like font experiments, because that is basically what we're doing. We don't need to add it to Git right now. The Git on this thing is kind of wonky right now anyway, actually. And maybe we don't even want it inside of here. In fact, I think I don't even want it inside of here. We're just going to cut that. I'm going to come all the way back outside of this. This is like gray now. Already open. Gray instead of white. That's weird. So the way that this is all connected is a little weird right now. This project is actually stored on the Raspberry Pi that I've been using sort of as extra coding agent. So Pi coding agent is a project. It's not, in this case, it's sort of confusingly named Pi because I'm running it on an actual Pi as well, but they're not actually necessarily related. But I talked a bit about that last week if anyone's interested in the setup that I am working on there. So I've been kind of using that a bit more this week, and I have it all set up here now to mess with this stuff as well. So this stuff is actually, these files actually exist on the Raspberry Pi, and that is wigging out my IDE some, especially because on the Raspberry Pi they're under another username as well, so another user account. Maybe this, yeah, on the Pi. So I have my user, and then I have the other user called agent, where I've got the Pi agent, the LLM setup thing going on. And actually thinking about it now, I've been giving thought to this all week, right? Because partially I'm kind of experimenting with this, getting different layers of sandboxing and stuff set up, and just kind of figuring out like where the pain points are for like connecting hardware and getting it to do stuff. I think it will be a lot easier, and just generally working on my development flow by like getting it onto this PC so I can see it and edit it and stuff. Just had the idea. I think it'll be easier next time if I make a default user that's not me, that's a different default user, and then I make me as the sub user, so like agent is now, then I'll be connecting as me, and then inside the Pi I'll have the reduced, like my user will have the reduced permission set. Anyway, we're getting off the trail, so that's not what I want to necessarily think about too much, but I did just have the idea. I do think that will make it easier next time, so it's good to kind of chew on some of this stuff in the back of my head as well. So this should just launch an empty window. Perfect. And what I am going to do is go and grab the bitmap font. I think there should be an example in here that does LV font, LVAGL font. And I think maybe, I think I recall Scott mentioning that this LV font thing, not necessarily in CircuitPython currently, but the LV font thing itself, I think maybe has support for anti-aliasing, which I don't think I ever actually spat out what I was going to work on, which is that I'm trying to look into some options for anti-aliasing inside of CircuitPython. Right now, all of our fonts, as far as I'm aware, all of our fonts are sort of bitmap on-off 1 bit. You have on pixels and off pixels. You can change the color. So like, you know, white and black is most typical, but you can change it to whatever color you want. You can even get fancy with rainbows if you use Displayio stuff cleverly. But what we don't have really is like anti-aliasing. So this idea of like, if you take white and black as an example, this idea of like the gray pixels around the edges that sort of trick your brain / eyes into perceiving sort of softer curves and softer lines and things. We do not have that sort of stuff. Don't have support for it to the best of my understanding. But this font thing I think maybe does. So maybe we can figure out a way to make it work. That's kind of the broad goal. I don't know if we will even come close to achieving that, but at the very least, I want to start looking into it and figuring out what do we have currently, what would it take to get to there. Essentially, that's kind of what I want to work on. We're going to need the font, which is here. Could probably just download all of this, honestly. I think what we'll do is just clone this. Okay. So that one was set to the code JA. And it also, actually, I think it wants it inside of fonts. Is that? Yeah, so it wants it inside of fonts, which I didn't do. And I also made this font. Should be able to find it there. This is my first time actually trying the LV fonts on Blinka Displayio thing, as far as I can recall. So I'm not sure if that's going to work. Unknown magic number sure did not. So I did not install bitmap font just now, and bitmap font has not supported this for too long. My suspicion is we have a older version probably. So let's do. Mm-hmm. Yeah, and we were 2 middle version numbers behind. Means we're a couple of features behind. Okay, it doesn't crash. And actually, I didn't look at the code, and I think this is probably doing what the code says, but yeah. So by default, this example is written essentially to avoid the whole Displayio stack. It's just outputting the bitmaps into the terminal. If I could ever find the right terminal again. It's just outputting the bitmaps into the terminal using what you call it, hashtags. Octothorpes. Is there a Displayio one? I mean, there is a simple test, but there's not a LVGL. Okay, so we're going to whip that together real fast. So this is not really what I want either, frankly. I want to load the font and then use the label. There we go. This is more what we want. Okay. We'll keep. Do we? I think we probably have a main group. I want to keep the main group. So loading the font. This is showing some metrics. We might as well keep that. Got this. Okay. It's here. A black background, so we'll do white. So I don't know. We do not need. We need load clip. So really, all we want to do is just set the label this, which we already did. So we don't really need any of this. I think let's comment it. We'll delete it if we don't. It refreshes text area. We need to add to the main group. There we go. Nice. All right. Okay, so that does work. Let's make it bigger because that's very small. Easy because we can scale it because label extends group. A little too big. But close. Oh, new lines. There we go. Again, it has emoji there as well, but they are mono. 1-bit. What I'm going for. I don't think there. I'm not sure if there's a mono color. Yeah. Okay, so we can render from LVGL font files. So the next thing we need to look at is are there some of these that exist already? LVGL font anti-aliasing. To see if there are any of these that exist already with anti-aliasing. Looks like so LVGL itself, according to this thing here, which who knows, but so far seems like it does. So you have to enable it in the converter. So we will maybe need to essentially export one. Both link to the same thing? Yeah, but different versions. X or 4x anti-aliasing automatically provided LV. Okay. Converting TTF WAF select BPP values higher than 1. Yeah. Okay. So we think pixel. I don't know about sub. I'm not sure we're doing sub-pixel, but maybe that means the same thing. Anti-aliasing to create smooth by enabling it in that using higher that or that for better quality. Okay, so maybe we should switch to black on white, but let's worry about that once we manage to render anything. Okay. So we need to find, well, we need to get a font that has anti-aliasing enabled when it was rendered into this format. And I'm guessing since this search did not return like a list of fonts anywhere that are just ready to go. The easiest way to do that's going to be to use the converter. So this is how we can get the right format. This is what we want to change. So ultimately, my hope here is magtag, which has 4 colors. So there's only 2 bits. 2 bits. 4 bits. Yeah. We should start small anyway, right? Let's not get ahead of ourselves. Go add in bits willy-nilly. We do want a binary file. We do... I don't know about this, so I'm going to probably go with no for now. This one, I don't know. I think I'm going to leave off to start at least. Try to use glyph color. Oh, interesting. What what this means exactly. Anyway, this is about, let's not worry about that. That's above and beyond. Okay, so if we could get a font, give it a size. What fallback would mean? Fallback, what does that mean, fallback? Font mon. Fallback. You know, it looks like it's a name. In case the name is taken or something? Name be taken. That would be falling back from. And if we can get a TTF file, then we can stick it in here. So whenever I am thinking of fonts that are permissively licensed, open source font foundry, got a lot of logos up in here now. Crazy. I kind of like this junction personally, but a lot of these are fun. We do want something where the anti-aliasing is gonna like help. Kinda though. Maybe this would be good. It's OTF. I have a TTF here though. Font converter says that. I don't know if it takes OTF or not, so I'm gonna give it TTF. Let's say it's called what now? Gaudy book letter? Gaudy. $11. I'm gonna say we're just gonna guess on the size for now. 20 x. All characters, no other fonts, submit, attach the file. Did? Like I did. Oh, there's a WAF also. Attach the font file. Thing I could think is like maybe the ad blocker, like sometimes the ad blocker messes stuff up. Maybe it's mad I didn't do this. Fallback. Nope. Anything more specific than? No? Anything. I believe this is all front end as well. This, yeah, it's not making network request. Have to put a range? One. Have any characters included? Range 0 to 0. I mean, I want the whole thing. Okay. I see somewhere there's a CLI also. I think I should read this. Like I did it out of order? Is that a range? Doesn't Like, help me. 20 to 7F, they say? 20. It's like ignoring one of them, right? I don't have a dash. I don't have a dash. Okay. But the form, yeah, as you can probably tell, the form, it does have validation. It believes that something is wrong. It tried to kind of sort of inform you what was wrong, but it's not specifically what's actually wrong with it. I wish there was just all, but I guess that's not how it works. Okay, so that gave us a bin file. We can now try to use here. I'll put it in fonts though. And we can't use this because I don't suspect that we have Japanese characters. Fall back to something English for now. Speaking of fallbacks, we get the regular name? Yeah, we got the regular. I still don't know what the fallback would mean. Okay. Yeah. Change this. Pretty this. That, run this. Okay. So that rendered. We don't have I don't believe there were any different colors in there. I actually want to bring some of this back. Let's do for H. Okay, so this is just saying. So this is like looping over a bitmap, essentially, right? Glyph.get glyph or font.get glyph. This is basically giving us a thing that's sort of bitmappy. It's a two-dimensional grid of pixels. We're looping over that. We are getting the current. Yeah, we're getting the current value of the bitmap as we loop through the X and Y coordinates. We're setting the hashtag as a string if it's greater than 0. Otherwise, we're just setting it as a space. But instead of string, what if instead of hashtag, what if we did value? Then we should get a number. So this should let us see if the data that we're getting from our font thing here has more than 2 colors in it, more than 2 index values. No, they're all ones. Okay. Maybe we should do the W because it has diagonals. And I think this matters more on diagonals. Still all ones, though. Interesting. Okay. So, next place we look is in the library. Inside a bitmap font, we are loading the font by calling load font. Basically going to trace through a couple layers here. We call load font. We gave it the file name. Our file name was bin. Although I actually do kind of like this one better because it's more specific. This calls into here. It's not that much code, so we can look at it. So this can create different kinds of bitmaps. So first of all, are we creating a bitmap? We just have bitmap, which is came from here, which we didn't pass, which defaults to bitmap. Okay, I don't know why that's like that. I guess I don't know what other kind of object. I don't know what else you would pass to that, but in any case, it can create a different kind of bitmap if one exists. Something that has the same interface as bitmap. I think you could use memory view or something maybe. I don't remember the specifics. Okay, so that should be default. So one thing to check is in here, are we even creating a bitmap with enough colors? Because if we create one that only has 2 indexes, then it will only have 2 indexes, and that's not surprising. But that'll be something to look for. So it's reading bits, it's looping. I think this is kind of like a buffer. So we're reading the file. Getting a section size, reading a table marker. The way the data is stored inside this file looks like has a series of tables. Each table has a marker. We have a head table, a CMAP table, a loca table, a glyph table. When we're in the head table, we parse out some details from the head table section of data, which presumably sets some of these things that then get put into these things. Load CMap happens here. I assume that's maybe character map. I'm not sure what loca would be. But it reads, similar kind of thing. It's reading data from the file. It's unpacking it into variable. Keeping track of it. And then glyph start just gets set for basically the end after everything. So it kind of seems like all this stuff is going to come first. Then there's going to be this. And this is basically going to have the rest of the data. I'm assuming we would read from somewhere. Of course, it could be CMap. Oh, but then why would it be up there? I don't know. The load head gets some maining section. Gets read out of the file. Font size, descent, line gap, turning scale, bunch of variable things. So a bunch of things get loaded from the head. Load the CMap, creates memory view of data. Data is the remaining section. Data, and then section start is I don't know what f.tel does. F is the file IO. No idea what that does. On file I. I guess we could do that. Okay. Current position. Seek and tell. Okay. So we read 4 bytes and then we get the index of where we're at after that, I think is what that's effectively doing. So that's a number. So load CMap is getting data and a number, an index. Puts the data into memory view. It is getting a subtable count, CMap subtable. So it sounds like there's going to be multiple subtables inside the table. Going to loop over those. Going to get a header for each one. Looks like it probably contains this data. Gets parsed out. CMap tables.append the info. We have not created a bitmap yet, I don't think. Some of these are just properties. Get bounding box. Seeks inside the file and resets some of these things. Read bits. Number of bits. Needed bits. Well, needed bits remaining. Byte file. Yeah, it's just literally reading bits from the file. Load glyphs. I think I actually ended up not doing that, right? We're not calling that. At least not firsthand. This code was, but current code's not, so I'm actually just going to skip that for now. Oh, maybe we shouldn't. That's the last thing. Do something's calling it. I think it's just like it gets called the first time you use it anyway, maybe, or something. What were we passing? We were just passing the string before, so file name. Oh, wrong file. Here we go. Okay, code points. So it can be an int, a string, or a list events, an iterable events. Okay. If it's a string, then we parse out. So basically, looks like we want to get a list of indexes, right? Of ordinal indexes of the characters. That looks like where we want to end up. So if we get a single int, we put it inside of a tuple, so that's iterable. If we get a string, we basically convert it to a list of code points of all the characters in that string. And if we got a list of ints, then that's what we wanted anyway, so we don't do anything. Only load ones that aren't cached. Okay. It is loading those, so we need to look here because it is doing self.glyphs.get. Goes to this, loops over this, subtable, file seek, suitable data, no subtable data. All right, so it looks like this is sort of, as it reads data, it's got like sort of state machine of like what to do based on what it read. What format it is, it looks like, is the terminology it uses. Yeah. Still not seeing any like bit mapping going on. Still no bit mapping that I've seen so far. Glyph offset. Read the glyph header data. A little bit of math, manipulation, bits. Create a bitmap. Create a bitmap 2. I'm just going to hard code it to 4. But we also have this here, which is going to have to get updated too. So this says read bitmap data starting from the current bit position. So this is like looping over that two-dimensional bitmap again, right? We're inside of binary data inside the thing or whatever, but conceptually we're looping over that two-dimensional bitmap again, and I think this is a guess, by the way. I stated as a fact out loud, but this is me kind of rubber ducking. I think that's what this is. Pixel value, read bits per pixel. So this is already tracking bits per pixel. We should print this out and make sure it shows 2 for the font that I loaded. But if it does, then our next hurdle is here. As the comment very helpfully tells us, this is ignoring the bits per pixel anyway. So what we would want to do here is not just if it's over 0, then put a 1. Instead, we would want to, if it's over 0, put the value that it is. And if this is accurate, then back here we can use it instead of hard coding, which is nice. So let's print this and see if it is real. If it is really set to what we want. Which all of this is a font file. We should, I mean, it's underscore, but, you know, more of a suggestion, really, I think. let's actually do the string. Okay, it's like, you can't do that, but I'm like, you know, I think we can have the technology. BPP is 2. Bits per pixel is 2, which is what we set it to. Awesome. Okay, very good. So then in here, so it suddenly struck me after I ran that. Oh, right, because we didn't change anything in here. Well, I changed this. Okay. I'm caught up again. I was like, how did my change actually, like, happen, get affected? Because I saved it in this file, but this file is not what's installed in the virtual environment. So for a second, I was like, how did anything I changed here make a difference? And the truth is it didn't, because the only thing we really did to get this was back out here. This is like at CodePy level, not in the library level. So what we do want to do is set this, except for, hold on, because so bitmap class, this does not accept bits though. This wants a count. So we need to not pass in how many bits we want to use. We need to pass in how many colors are possible with that many bits, which is 2 raised to that number? Possibly? Yeah. Yeah. So this would be 2 raised to the power of bits per pixel. So now we create a bitmap with enough colors for however many bits we're using. When we read here, if the pixel value is greater than 0, not doing this anymore. Instead, we are putting the pixel value here. And theoretically, if this number lied to us, then this could be like out of index range. But as long as this number did not lie to us, then this should be in the valid range, I think. So we can do this. Now, the next thing is, though, I can run... Well, so we will need to install this, because like what I was saying, this is not in the virtual environment. If you need to do upgrade, if you do it that way. Okay, and so now the thing is, we could run this again. Hopefully it's not going to be broken, but it's not going to work either. So there's like, it doesn't look good. But what we see here is the good stuff. So now we have more than one index. We have more than one color. Each one of these numbers represents a color in our final bitmap. We now have 4 total. The zeros are not printed because they're off. We have 1, 2, and 3, so we have 3 other colors aside from the 0 color. So that now looks good. We just need to get this to render into the bitmap next. Which... we need to probably go inside of bitmap label, or whichever label we're using. Well, that was way faster this time. Okay, bitmap label. So we really want like the meat of this is where it's pulling data out of the font and putting it into the bitmap. Font. I mean, there is blit, but that's not what we want. I mean, it would be from where this gets called, maybe? Actually, it's already... Okay. We're actually further along than I thought. So we don't have to change anything in here. We don't have to change everything. I don't think we have to change anything where it's pulling data out of the glyph, putting it into the bitmap, because it's using blit to do that, and blit already copies pixel for pixel whatever values are there, which is why we have holes, right? We have... This is all pixely and splotchy like Minecraft or whatever now. We're missing the other pixels. We're only showing index 1 or whichever one it's showing. It looks like it would be index 3 actually. One thing we'll have to figure out is which way does the palette supposed to go. So like before, we had 0 is off and 1 is on. So with our color scheme now, 0 is black, 1 is white. But now it looks like sort of 3 has become the full white. So we need to like downstep from there back to 1 in our palette. Where does the palette get created? Here. It is hard-coded to 3. Okay. Fork in the road. Do we start right now just hacking up bitmap label to try to change it to support multiple colors? Or do I try to make as little changes inside of it as possible and instead hack it together from the outside to get a proof of concept working, to work through all the things we're gonna have to work through, so that once we start actually trying to update bitmap label, we know what we're doing better. I think I like that option better. So for one thing, we will need... We need a custom color palette, which we can pass because of outlined, I think. I set this up. But we can... and accents as well, which are like... it can highlight a section. But and we can use more than one... We can have more than one color, I believe, in fact. We can just give it a palette of arbitrary colors. So we might not even need to actually technically change anything inside of here, which would be super sweet. Okay, so let's go back to here. Where we create the bitmap label, we want to make a different palette. So before we just had black and white. What we want now is a palette, custom palette. We're going to have 4 colors. Custom palette. 0 is actually going to be black. Same as it is today. Not today, but same as it is with this. We are going to have 3 be white. Might be time to swap anyway around, but let's do it this way first, and then we'll swap it. I get. So realistically, I want to try to land on the colors that the mag tag has, but I don't remember what they are off the top of my head. I mean, I think it's like as long as you get close enough, it work it out. But so if we have a custom palette and then we go, don't need color if we do color palette. Color palette. So save that. Cool. Label based init got unexpected. So that I think is similar to bitmap font. This is the same deal. The thing that's installed here is old. I think I just need to get the new one for display text. Yeah, we had 3.24, 4.02 is the new one. And color palette was added with one of the new things, so I think that's definitely... There we go. Okay, so we do... that still looks the exact same, I think, right? That still looks the exact same. This is still rendering... like, only the 3s. Oh, I don't want to install it from pip, do I? Oh, it should be fine to install it from pip because I didn't make any changes in here. Okay. Yeah. Should be fine. Okay. Let's trace through this a bit more. So we have our color palette now. We should have enough colors in it. Not messing with accent ranges, reset text. Look for the empty string, calculate some things. Calculate some more things. Place text. That's not what I wanted to do. Place text. Place text takes a bitmap, the text to place, the font, position, skip indexes. Yeah. It gets some numbers. It loops over the characters in the text. If it's a new line, it's special and it does whatever's there. If it's not a new line, it gets the glyph. Should, and that's the same thing that this is doing. And we know this is getting the 0, 1, 2, 3. Like we're printing that out here. So we know that should have those numbers in it. If the temporary glyph bitmap is none, and the length and there are accent ranges, then it's creating a bitmap. Wouldn't we need a temp glyph bitmap regardless of whether or not there are accent ranges? Interesting. I guess this is creating it. It's created as none the first time. How does it get created if there are no accent ranges? Or is there always one accent range? I'm just gonna uninstall that. I don't think we technically need to. Install the one we edited. Alright, so that never got created here, theoretically. But that is the only other spot where it gets created. Unless it happens in label base. Which it doesn't, because it doesn't exist. Maybe we don't need it? Maybe it's only used for accents. You call it like accent glyph bitmap or something, temp accent. If that it turns out to be the case, that's my working theory right now. So I guess let's keep tracing. So if my glyph is none, so if we failed to get a glyph from the font file, then just print a thing and don't do anything else. If we did get a glyph from the font file, math stuff, math stuff, math stuff, more math stuff, math, 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 accented. If there are accents, do the stuff that's in there. We're not, I don't think. So if there are not accented, if we have outline accent, no. This needs more parentheses. I don't know the order of operations. So not accented and has outline accent. First of all, that's wonky. Or accented and foreground background, then do this. I don't think this applies, but I'm not sure because there should be parentheses here to show order of which things go with what. If accented, again, we're not accented, I don't think. And we get all the way to here, we blit from bitmap. No, actually, I don't know what the order is. That's okay, 2. So we blit 2 bitmap, XY source bitmap. So from the myglyph bitmap, and then yeah, here. So if it's not accented, we do this. If it is accented, we do that. So we only need this if we are accented. That's why we never created it. It's doing some skipping indexes, but I think it should be none in our case. Or 0. Skipping 0 should be fine. Because we technically have a different thing for the background. Yeah. Do not copy 0 if it's not accented. So myglyph bitmap. We're going to turn this off. I'm going to go inside of here, and right before we blit, I'm going to wreck the formatting. We are gonna do all of this stuff. But it is my glyph. And we need C, I guess, if we want to actually print that. I'm just gonna take out the C though. Actually, we don't need to. We already have my glyph, which came from C. Theoretically, we could go back there and find it, but okay. So we do. We definitely have different colors in the bitmap we're copying from. Map we're copying to. All right, BRB. Okay. New plan. All of that off. Oops. Here, I want to do this, but I don't want to loop. I don't want to loop just a static glyph. I want to loop the entire bitmap of the label. I want to loop all of the characters basically the same way that this is doing. I think we should be able to do this. Okay. So our bitmap definitely has colors in it. Let's go ahead and swap the colors around. Oh. Yeah. All right. So somebody forgot to put the right indexes in there. I'm not trying to point any fingers, but that could certainly have something to do with our problem. We do that, and now it works. It looks a little weird, but it's got the grays in there. And it said somewhere we read earlier about looks better, I think, the other way around, right? Dark colors in back. No. Dark colors in front. Light colors in back. So let's go ahead and swap these right around. I don't think this will work yet because the background is still black. But we could do this, I think. Yeah. All right. Cool. I don't have the camera set up. Maybe we won't go all the way. But like I said a little bit ago, my true aim for this is MagTag. We got this working here, and it seems like it should work and do what I want. So this is really cool. Theoretically, we could do a higher bitrate as well. I mean, now that we sort of have everything working, this lets us go all the way up to 8 bits, which would be 256 different colors. I don't have a super duper easy way render a palette. I could use the gradient thing? Or a gradient thing in the is it fader? Currency is preserved. You have a source palette. You have a brightness. So in order to get a full gradient here, we would have to run it through a loop of different brightnesses. Yeah. And then compile together the results. Okay. Let's try this. It takes a I'm gonna call it a start color and an end color just because that's kind of how my brain thinks about it. We could say foreground, background, except it would be foreground? These backwards? No. that takes a start color, end color, and count. Generates and returns a palette object like. By a gradient from the start color to the end color with equally distant steps. In between to equal. That means setting colors in the palette looks like read a bunch of files. Oh. It's totally hit V instead. Stuff, man. It's all got a cross on it. Extra spaces everywhere. That's one thing I have found. Well, I mean, I guess it's because I'm holding it wrong, as they say. I'm copy pasting out of the terminal. Like I should have told it to write a file, I suppose. Wouldn't have been a problem. Copy pasting out of the terminal, I end up with a bunch of extra space where I don't want it. But yeah, that's kind of a problem. I should have told it to write to a file. So this will make a gradient palette. So let's try making a gradient palette that's bigger. Go from white to black still. But count, we're gonna have 256. Then custom palette is gonna be 256. Passed in there. I don't know why I pasted. Background color is still white. So if we re-export this font, 8 bits. Should have called the other one 2-bit, huh? 8-bit. $12K instead of $3K. Keep it. X out of bounds on dimension 1. Maybe We're probably off by 1 somewhere. Let's make sure the BPP value is correct. Okay. So I think that it's possible we're just kind of off by 1. Like we're trying to put 256 as the index in and can't because 255 should be the max. What length is 256? A pixel. Well, this is into bitmap though. We don't need to go that far. Pixel value. There, I guess. Print. I mean, pixel value must be too high. Get to there. Oh, I didn't install it. Five. But it tries a bunch of times, actually. So maybe it is actually XY. Just F. Hmm. And I mean, here it does look like it would be the X dimension, but why would... Why would 40 be outside of the dimensions? Hmm. We keep everything else the same, but switch this back to the old font. Does it work? I mean, it won't look right, but... No. It did make it farther. Maybe... But well, this one's not going through. But this is only when load glyphs gets called. We would only see this at the beginning. So I think we are like inside of one glyph. We're back to the old. I don't know what I did to break it. I mean, is this making a pallet and returning it? We count +1? Maybe it created the pallet wrong. Oh, can you do this? I'm not sure if you can do this. Huh. Okay. Hmm. Hmm. Why did that go longer? Did it? Why? It did a bunch of extra stuff, I thought. Well, okay. The range, the for loop iteration just didn't work. But now I'm looping by index and it does. But still, when you get into here, it seems to think that it's out of bounds. But again, I went back to the 2-bit font. We're back on the 2-bit font. And if I change only the palette, then it works. So I don't see any way that if the only thing I'm changing is the palette, I don't see any way that the X can really be the thing that's out of range. I feel like the value kind of has to be the thing that's out of range. Again, if the palette is the only thing I changed and it caused the difference. Yeah, this time I do just want to edit it. Do I? Guess I'll... In any case, the 4-color one is really what I want for the mag tag. This one would be cool, but I may not spend too much farther trying to fight it, really. But like right now, I mean. I'd like to get it working eventually for sure, though. Alright, so BMP width. Care about skip index. Yeah, I guess let's do that for now. I mean, this doesn't really help us, honestly, actually, though. This doesn't really help us. We can run it, but it doesn't really help us. By 50. Understand how the palette could ever affect the X. One thing we could try is making more padding? But bigger thing now. Place here. And it's only setting values. I mean, it's not using the full range. Fair enough. Hmm. Um, what if padding right was bigger? Oh. Hmm. So that branch of logic is specific to 1 byte. I wonder if we try this, what happens? And hopefully I'll probably be heading out after this, I think. But we actually got way farther than I thought we would, so it's really cool. I think we should be ready to take the 2-bit, the 2-bit one onto the mag tag. Probably do that this week. Let's try 4-bit. Yeah, the palette. Right. Let's try 4-bit. I mean, I think that has to be. I almost think that has to be a bug in Blink Displayio that happens to be. That happens to occur when you have exactly 1 byte of numbers of colors, when you exactly have 256 colors. And it seems like there's different logic for before and after. And it might be the case that the logic for exactly 1 byte, this could be wrong somehow. Okay, so we do 4-bit, and then let's do count 2 to the 4th. There we go. That one works. Yeah, I don't know. I think there might be a bug on specifically the 1 byte color count, the 256 color count exact on the nose. I think that one might have some kind of off by 1 or other index value error situation happening. But here, even on the 4-byte one, we can actually start to see the improvements of how this looks. The 2-bit one was not looking so great on this screen still. I do think the 2-bit one will look a lot better on the MagTag screen, though, being the e-ink. This one, though, we can really start to see with 16 different colors here, we are really starting to get some of those smoother lines that are indicative of like font that's like not, not just super 1-bit pixelated, right? So this is super cool, very promising. Yeah, high res. Yeah, and I know Scott's interested in the bigger displays as well, so this will definitely help in that world once we start getting into some of those much larger displays. This would be cool on the Fruit Jam as well, where we've got the HDMI, DVI output looking thing. So, all right, I think I am going to wrap it up here. This is pretty sweet. I am definitely happy with how far we made it. It was actually pretty easy in the end because the font format already supports it. The converter can output it. The input code that's parsing the file needed to be adjusted, but only slightly. It was tracking one of the things it already needed to track. We just had to adjust it to like not, just use 0 and 1 only. And then that was pretty straightforward. I don't think I ended up changing anything inside of bitmap label that actually mattered. but I don't remember for sure. We did troubleshooting, and I changed a bunch of stuff in there, so I'm not sure if anything mattered. I don't think so. So yeah, with just the one tweak in bitmap font, I think we could have this working, and I'm excited to try it out on the MagTag. All right, thank you everyone for watching. Hope you all have a wonderful rest of your Saturday and a good weekend. I will be back, as far as I know, next week at the normal time, 28th at 10 a.m. Central Time here on Saturday, to work on some more CircuitPython stuff. It's kind of interesting how the spaces in here got wonkified, but I don't know what's up with that. Looks like it just didn't render the spaces correctly. In any case, it looks good on the screen. All right, yeah, take it easy, everyone. I will see you later.